Hi, my name is Ala Zarbi, 6216480. Van is an electrical machine which is based on a motor which rotates. To control the speed of the van, we need to control motor, and motor speed depends on the voltage and current applies to it. So, to control motor speed, there are various methods. We use the method by controlling current. A transistor is an electronic device whose collector current is controlled by base current. So we connected the motor between collector and power supply. And in order to avoid reverse current flow, we added a diode to bypass the reverse current. Now we control the base current by using the potential meter at base terminal. In this way, we control the base current as per the desired situation. This is how we designed the circuit. We implemented the circuit on hardware too, but before that we simulated the circuit to verify our theoretical knowledge. For introduction, for industrial systems that require good monitoring of speed, command and respond, control speeding is very important because of their simplicity, ease of use, reliability, and low cost. DC drivers have also long been the backbone of industrial application. DC motors are integrated and have torch speed signals that are compatible with many other mechanical loads, making them controlled in a variety of modes where the final voltage is carefully controlled. On a separated DC drive, a simple procedure can be performed by reducing the power of the arms below the estimated speed or increasing the flow of the field to get a lower speed than the estimated power. A bipolar junction transistor (BJT) is a well-known semiconductor device that is described in detail in many assemblies in electronics or semiconductor. These transistors are now control devices. Semiconductor, metal oxide, field effect transistor is the field effect of transistor. It has VAR gate, its power determines the performance of the device. This ability to change the flow of applied energy can be used to amplify or change the signal strength.
It's Khaled Al Najm, 6156899. For the final project prototype design specification, as you can see, if the MOSC is bound as a source follower or a normal output mode, you can see about this setting which discussed the BJT version, but the operating principle remains the same, and the DC motor control design above. Adjusting the potentiometer creates a potential differential difference across the MOSC gate, and the MOSC source pin simply detects the potential of this potential difference and adjusts the voltage across the entire road accordingly. This means that there will be 4 or 5 volts remaining on the same gate power, and this difference will be very up and down, providing switching power between 2 volt and 7 volt in the car. When the gate voltage is close to 7 volt, the source pin will provide a minimum of 2 volt to the car, causing a slow rotation in the car, and available with a 7 volt source pin. When the potentiometer adjustment produced a 12 volt through the MOSC gate. Here we can clearly see the MOSC follows the source pin gate and is therefore the name of the source follower. This is because the difference between the gate, and the source of the MOSC pin um, should always be around 5 volts, allowing the helper to function properly. Um, Custom circuits have a variety of speed control devices such as IGBT um, and MOSFET. The bipolar IGBT or remove gate transistor is a solid state of the art component um, consisting of moving parts like a helicopter. Using IGBT provide fast switching, high efficiency, and low switching losses. Thyristors of the of the other hand were transformations of traditional ministers of power control in industry. The current era of a solid-state power electronics began with the introduction of this device in the late 1950s. Basically, is the file starts on the operating device that can be replaced with an ongoing positive gate pulse. When the device is switched on, the negative gate pulse cannot be switched off, and the device opens the process very quickly, and also its closing process is slow because some carriers have to be removed of internal crossing.
Hello everyone, this is Abdullah Al-Dihani, Panther ID 6161516. Analysis of results and tests. Engine speed compared to PWM is displayed on the integrated LCD. For compression purposes, a speed meter is used to measure engine speed and percentage errors are calculated. The motor does not potentially react strongly to the PWM, but it starts with a shock after the PWM is adjusted to a higher stride width. This does not mean that there are problems in the circuit. It is because the DC motor armature is holding tight between a pair of magnets. To start the armature, its rotation must be released by the two poles of the magnet, which must not be with a slow and gentle motion. It should start with a push. Now to conclusion. Electric driving is a component of our everyday life expectancy. In this report, the MOSFET-centered food process DC propel motor powered quickness magnet technique was developed and built. This regulator has many 210 bibroless and a percentage error from 1.10 to 14.28 in the 12-volt power supply. The complete price tag of a velocity management system is $18. Barely such a push would be more appropriate meant for family manufacturing equipment. Thank you.
And for the future work, electrical leads many submissions in various industries such as moving rides, rechargeable sleepers, and mechanical spin doctor. An efficient motor will self-destruct the speed control device, potentially leading to a serious accident as well. In this design, the low charge MOSFET created DC electric motor speedness controller method was considered as a manufactured in this scheme. The response electrical energy from the load up is monitored by a speed regulator of the DC motor. Measurements show that with a maximum velocity of 210, the error rate of the 12 volts supply voltage ranged from 1.10 to 14.28. The aggregate price tag of the motion control plan is only $18. Such drives are suitable for internal industries equipment for DC motor speed control.